Good afternoon, everyone.
Good afternoon, ma'am.
Good afternoon.
Good afternoon, ma'am. Good afternoon, ma'am.
Okay, so we are doing the asymptotes. So we are looking at the asymptotes. Okay. The implicitly given equations f of x y equals to 0. Okay, so horizontal asymptotes we know if we equate the coefficient of the highest term for the horizontal one, highest term in x. Okay, if you equate the coefficient of the highest degree term x, okay, highest degree term of x, the coefficient we will consider and we will set it as 0, then we will be getting the one horizontal asymptotes. Just a minute. Okay, so we are looking at that, and because the coefficient of x highest degree term will be in terms of either y. See, if it's a constant for the highest degree term, there are no horizontal asymptotes. Okay. Similarly, if you look at the highest degree term of y and its coefficient is will be in terms of x, but if it's a constant, there are no vertical asymptotes here. If this g naught x is a constant, then that means their x terms are absent, no vertical asymptotes. Only if x terms are there, you will have the vertical asymptotes. And there is one thing, the what is the maximum number of asymptotes? Any idea? Maximum number of asymptotes?
Ma'am, number of order.
Order? What is the order?
Order of the function g naught x.
Order of the function g naught x. G naught x, if it's the coefficient of y, and then it will give you only the vertical asymptotes. What I am talking about, if a curve equation is given, equation of a curve, what will be the maximum number of asymptotes?
Order of the given polynomial, ma'am.
On that order, it's the degree, highest degree. Okay,
Yes,
we are
ma'am.
not,
Degree. Sorry.
order comes when differential equation comes. Differential, the first order differentiation, second order differentiation. Okay. So maximum number of asymptotes of a curve. Okay, if equation is given, then it will be less than or equals to the highest degree term. Like if you have the nth degree equation part, then your number of asymptotes, you have a cubic polynomial, suppose the equation is a cubic equation, so there will be maximum 3 asymptotes. Okay, there won't be 4 asymptotes. And when I'm saying highest degree term, we will consider the implicit one. Suppose you have x cube y plus y cube plus x square y, then this is the highest degree term. Okay, the degree of the equation you will consider 4. Okay, if individual term, this is the only highest degree y term. Okay, but this is the highest degree of the equation. Got it? This you remember. Okay, when you have in the implicit form. Okay, because mostly the equations are will be of this form, so you have to combine both. Okay, if you have the terms containing both x and y, you have to add this two, so their degree is 4. Okay, so degree equals to 4. Got it? So we're looking at the oblique. Okay, once I will do the oblique one, then we will go for the. Okay, one note we will put. Since see, we are to obtain horizontal asymptotes equating to 0, the coefficient of highest degree term. Now, if the coefficient is a constant, we cannot put it as 0, so there won't be any um, vertical asymptote, horizontal asymptote, and the same thing here also vertical asymptote. Like suppose here you say x cube coefficient is y, so you can put this y as 0 and y equals to 0 is the x-axis, that is asymptote to this curve here. But this one, see if you look at this term, okay, this is the highest degree x term, highest term, x degree term. Okay, so the coefficient is of x cube is y, so we will set y equals to 0 as the asymptote. Okay, x-axis. So this is horizontal asymptote. Okay, I'm writing it this way, horizontal asymptote. Similarly, let me write here. Vertical asymptotes. Okay. And the oblique one or inclined, okay. Okay, let me just do it for this one. Now, if you look at this one, see, this is y cube, highest degree term of y. Okay, and this is having degree 3, but highest degrees are x cube, y cube. Okay, so y cube coefficient is 1, so you cannot get it to 0. Okay, so whenever you have constant coefficients, you can say no vertical asymptotes. Okay, so here we have no vertical asymptotes. Here we have only one. This is your horizontal asymptotes. One asymptote we. So maximum we will look for 2 more asymptotes. Okay. So there will be either two, maximum 2. Okay. It can be also one asymptote. Okay. It's possible you can have 2 asymptotes. So here we see we will write then oblique asymptote. So how we find the oblique asymptotes? So okay. OA will stand good. That's why I didn't write the inclined asymptote. Okay. So here we have a method here. Okay. So we can say, like we can assume if there is a oblique asymptote, it's a straight line. So equation will be equals to y equals to mx plus b. So let y equals to mx plus b be an asymptote. Okay. So if it's an oblique asymptote, okay. So then the points of intersection of the curve and the asymptote satisfy the equation. That means in the equation we will substitute y equals to mx plus b. Okay, they meet at the infinity, but we can do that. Okay. So if they meet, then we will substitute y equals to mx plus b in the equation. Okay, assuming that the points of intersection of the curve and asymptote satisfy the equation. Okay, so we will substitute y equals to mx plus b. And we now equate to 0 the coefficient of the highest term of x and the next highest term. Okay, so this will give you two equations in two unknowns, m and b. Okay, so if you have f of xy equals to 0, here this is the equation of the curve. So what is the first thing we do? We substitute y equals to mx plus b in f of xy. So what we are actually getting is f of x and mx plus b. So 0. Okay. So the next thing what we do, we equate to 0 the coefficients of x power n, where we say that x power n is the highest degree x term. Okay. Okay, so the highest degree x term and the next highest degree of the x term, we are equating both the coefficients of these two to 0. Okay, so we will be getting two equations and two unknowns, that is m and b. Okay, then okay, or this gives two equations and two unknowns, m and b. Okay, and solving this you can get the values of m and b. Okay, let's do one example. We can get m and b values. Okay. So the first equation gives all possible values of m. Okay. First equation gives all possible values of m. And the second equation gives the corresponding values of b. Second equation gives all corresponding values. Okay. Second equation gives the corresponding values of b values. So, and what happens if a particular value of m, the coefficient of x n minus 1 becomes 0? We equate to 0 the coefficient of next highest term of x n x. Okay. That means x n minus 2. Okay. if for a particular value, okay, we will do the examples. What I have written here, so that is, so if for a particular value of m, the coefficient of x n minus 1 becomes 0, then we go for the next highest term. Then we uh, equate to 0 the coefficient of next highest term, that is x power n minus 2. Okay, and it will go on. If x power n minus 2 becomes 0, we will go for x power n minus 3. Okay, so we need to number of values, whatever number of values of m are there. Okay, so here in this case, okay, so let's do one simple example where we will see. Suppose here our example is f of xy equals to x cube plus y cube minus 3axy. Okay, and this curve, this equals to 0. Now the first thing we will substitute y equals to mx plus b in the equation. So that means fx mx plus b. So this will be x cube plus mx plus b cube minus 3ax mx plus b. Okay, and this equals to 0. Okay, so now we will collect the terms. Okay, so here we will have x cube plus m cube x cube 3m square x square b plus 3b square mx plus b cube. So, and here we will have minus 3am x square plus 3abx equals to 0. Now we will collect the highest degree terms. Okay, coefficient of x cube. So 1 plus m cube x cube. Then for x square we have this term and there is one term. Okay, so 3m square b minus 3am. So this is the coefficient of x square. So we can take common 3m here. Okay, and we can write it as, if you take common 3m here, 3m we have bm minus a. And similarly 3b square m, 3ab, so 3b we can take common. So again bm minus a x plus bq equals to 0. So the things, we will set the first two terms as 0. Okay, so this one and this one. Okay, so equate the coefficients of x cube and x square to 0. Okay, so 1 plus m cube equals to 0. So we are getting m cube as minus 1 and the value of m is minus 1, and rest of the two values are the complex values. Okay, so we will go for m equals to minus 1. Okay, so we have m value here. Then we will look at this one, 3m into bm minus a equals to 0. So we already have m value. So we will consider only this part will be, m is non-negative. So we are left with this option only, bm minus a equals to 0. Okay, and if you put b value, m value as minus 1, okay, this is minus b minus a equals to 0, and we are getting b equals to minus a. So we have the value b equals to minus a. Okay, so if you substitute, okay, for n equals to -1. Okay. This is the v value. So y equals to mx plus c. Minus x minus a. So this is one asymptote. Okay, or you can further write x plus y plus a equals to 0. So you see this is a oblique asymptote. Okay, and we don't have here horizontal. If you see here, okay, so here no. See x cube, the highest degree term of x, its coefficient is 1. So we cannot equate it to 0. So here we have no horizontal asymptotes. Similarly, here the coefficient is 1. So you cannot equate it to 0. Only if it's a function of x here or here function of y, you can do that. So no vertical asymptotes. Even if it's a third degree one, we have only one asymptote, x plus y plus a. Okay. So it's like an algebraic equation. If you have an equation of degree n, it is having maximum having n number of roots. So similarly, what I said here, number of asymptotes I was talking about, the maximum number of asymptotes of a curve is less than equals to highest degree term. If it's n, then it's n. Okay. So let's do some more examples. Find all the asymptotes of the curves. Find all the asymptotes of the curves. So 1 y square into x minus 2a equals to x cube minus a cube. Okay. I think you can try. Whenever you have the things, you first look at the highest degree terms here. So at least for this one, you see you have, if you go for the solution here, first one, the highest degree of y is y square. So you can substitute this word, x minus 2a equals to 0. And you have x equals to 2a. Horizontal asymptote. And you see this power is 1. So no vertical asymptotes. One asymptotes we are getting. Now you look for the oblique asymptotes. Okay. Try opt for the oblique asymptotes. Substitute mx plus b in the equation and find it.
Two oblique asymptotes.
Any doubt? You got the oblique one?
Two ma'am.
What is that? I couldn't hear you properly.
Two oblique asymptotes.
What are they? Two
Ma'am, first
oblique.
equation is coming.
Yes. You have
Y
substituted.
equal to x plus a, y equal to minus x minus a.
Yes, ma'am.
So you substituted that.
Yes, ma'am.
Yes, ma'am.
So if you substitute, what is the equation? Y square into x minus 2a. Then we have x cube minus a cube. So हाँ कल्पना. Okay, so where we are. So we substituted here y equals to mx plus b. What we are getting? So you tell me next what happened. Highest degree terms. 1 to
X
10.
cube in bracket,
X cube
in
bracket
bracket, m square minus 1.
m square minus 1.
Ha, yes, ma'am. Plus 2mx
Then
square,
plus 2
mx square,
mx square
in bracket b minus 2a.
b minus 2.
A.
This is
Ma'am,
b
next
minus.
time we don't need it, no?
No, we don't. You didn't write. But suppose. But it's a very small expression. You should write it.
Yes, ma'am. Then x.
See what happens when the
I
x
did not
square.
make it common.
Okay, only you wrote it, and we have the other terms. What happens if the x
Ma'am,
square
then x into c square minus 4amc.
x into
C square whole multiplied
c,
whole.
c square? Where do you get
Ma'am,
c?
that's B. Ma'am,
Sorry,
that's
you are
B.
taking
Ah.
B. Actually, I took C.
Okay,
So,
okay, okay. It doesn't matter. X b square.
ma'am, whole bracket, whole bracket, inside bracket, b square minus 4amb.
This one.
Yes, ma'am.
Then is there any term?
Minus 2ab square minus a cube. Yes, ma'am.
Okay, this much. Okay, okay, okay. Thank you. So we equate this to
Last term
0.
plus a cube.
So m square minus 1 0. We are getting 2 plus and minus 1. So correspondingly we are getting. So we already have, you see, it's highest degree is 3. So we already have one asymptote. So we will maximum look for 2 asymptotes. Once you get 2, you stop because other things will repeat. Okay, you solve it, but you will it will be repeated. Then we will look at the next term 2m into b minus 2a. So we'll put it as 0 and m is non-zero. So we have b minus 2a equals to 0.
Ma'am, B
Is it
minus
coming
2
B?
a.m.
B minus
Yeah,
2am.
2 a.m.
okay. So
Inside the bracket.
otherwise, it's coming
B equal
cons
to plus or minus a.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
am. Okay, so b is coming to am, and for m equals to plus and minus 1. All right, plus 1.
Ma'am, there above m equals to plus
Ma'am,
minus 1.
2
You
B.
wrote m square.
Wait a minute, just a minute.
Ma'am, B minus AM only, ma'am. Already we common 2, no, ma'am.
Yes, ma'am. B minus
Yes,
AM.
ma'am. B
Ma'am,
minus A.
not 2A.
AM. Okay. So M equals to 1. So we have B equals to A. For M equals to minus 1, we have B equals to minus A. Okay. So we have this. I've already written this one. Okay. Now you already said me. So these are the three asymptotes. We will not go and check for the others. Okay. Then so here the next one. Then try the next two. Okay. If you are done, you just let me know. The second one.
Ma'am, can you please show the question once again?
Sure.
X equal to plus minus a vertical asymptote, y equal to 0 horizontal asymptote, no oblique.
No oblique asymptotes. No oblique asymptotes. No one is getting. Okay, let's see. Y square, a square minus x square. Okay, so you can see here y square is the highest degree term. So the coefficient, if you put this one to 0, a square minus x square equals to 0.
Yes, ma'am.
Then we
Only
have
horizontal asymptote.
plus minus a.
Yes, ma'am. Only this one.
Okay, and for
Vertical too.
so these two are horizontal asymptotes. Okay, so it's a fourth degree term, so maximum 4 asymptotes. Okay, so horizontal asymptotes are 2 we are getting, and for x square, what the coefficient will be y square. So y square equals to 0.
That
So
will
y
be
equals
vertical.
to 0.
Vertical 2.
Sorry, that will be vertical. Na?
Yes, ma'am.
Yes, ma'am.
This will be vertical. This is vertical asymptote and this is horizontal asymptote. Okay, we will check for the oblique you are not getting.
No, ma'am, we are not getting.
See, I will give you a general form where you can check. Okay, a general format and easy format. Okay, it's there, but it's a little bit cumbersome they have done. Okay, that one of the
Ma'am,
techniques.
repetition, ma'am. Here also y equal to 0 came, ma'am. M value 0 and B value also 0.
Okay, I'm giving you something else. Okay, one a different formula for the oblique asymptotes. Okay, because if you proceed in the same way, you may not get it. Okay, like if you put y equals to mx plus b. Okay, so the equation becomes x square y square. Let me write this one minus a cube x equals to 0. So what we are, if you substitute y equals to mx plus b, what we are getting is pi 4. Let's substitute first. Okay, so if you put here x square y equals to mx plus b square, mx plus b square minus a square. So if you have done the simplification, you tell me what is, so here the highest for x cube, what is the coefficient of x cube?
X to the power 4 is
4
the
ma'am.
x to the power 4.
Minus m square.
Ma'am,
X, oh, okay, sorry, x to the power 4. What are the coefficients of that?
Minus m square into x to the power 4.
Minus m square.
But only this
Only
much.
minus, only minus
Yes,
m
ma'am.
square, right?
yes, ma'am.
Then x cube
Minus 2 MB.
minus 2 mb. Then plus x square,
A square M square minus B square.
a square m square minus b square. This much. Done. Thank
Yes,
you,
ma'am.
X. You have done told me the right equations. Okay. All of you check because
Ma'am,
where I, yeah.
Ma'am, you written wrong ma'am.
yes, ma'am. For
Where,
X also we have
X
two
also we have
coefficients.
coefficients.
oh, sorry. So
For
I
X we
asked you.
have, ma'am, that's plus X, 2 MB A square minus A cube.
This
And then
much? No,
plus,
it's okay.
Plus a square
and
b square.
plus A square B
Plus
square.
a
A square b square.
square b square. Okay.
This much.
So here, okay. Mm. What I'll be telling you, just a different thing, a working rule actually you can say here. Okay. So here, so suppose here y equals to mx plus c is the oblique asymptote. Okay. So here what we do here, put y equals to m and x equals to 1 in highest degree term. So when I am saying highest degree term means it can be for only x, can be for xy, and can be for both combined xy. Okay, you have to look at the highest degree terms. Okay, so okay, so actually what we are doing here. Suppose I'm let one example I'm considering, and side by side I'm doing this one. Okay, um, some equations you write phi n. Suppose n is the highest degree. N is the highest degree of equation. Okay, so here first thing we will do is we will set phi n equals to 0. Some equations I'm giving you. Okay, let's look at it. I didn't go for the derivation, but it works very well for oblique one. Okay, So these are the equations you have to remember, because if you look at this one, you will be getting m values, then you can get c values. Here I have written mx plus c. You can also write, since I'm writing b everywhere, let me write b here. B. Okay. And here also b. So these equations you remember. Okay. Then we can have b squared by 2 factorial phi n double s. Phi n I have written. Okay. Then plus c by 1 factorial phi n minus 1 dash is phi n minus 2 equals to 0. So b cube by 3 factorial. So similarly, you can keep on increasing this one. Okay, once you don't get it, you have to go like this. Okay, then b square by 2 factorial, and here we have the second derivative, b by 1 factorial, one derivative, this is n minus 1, n minus 2, n minus 3. Okay, so this is the way of the equation. It can increase also, but up to 3-4 degree it will be this many is enough. Okay, and here we will do one example. Okay, and there we will see. So let's do one example. Okay, this I have written. Okay, afterwards also there. Okay, for higher degrees you may need, but I think up to 3-4 it will be enough. Okay, so for the oblique one, okay, let's see. Okay, one example you see. Example. So here y cube plus 2xy square. This one I am doing one example. Okay, you will be doing the last one, what where you didn't get the oblique one. So here, so you can see the highest degree is 3. Okay, and you see these are the highest degree terms. 3, here 2 plus 1 3, here 2 plus 1 3. All these are the highest degree terms. Okay, now we will, if you look at the phi 3. Okay, so you put, so putting here what I've said. Okay, phi in, how we will put y equals to m and x equals to 1 in the highest degree term, and then we will be getting the phi 3. So suppose the degree is 3, so putting y equals to m and x equals to 1 in degree 3 terms. All the terms having degree 3. With this.
Excuse me, ma'am.
Yes,
Please scroll down the example.
this one. See how we consider phi n means, mute yourself. Mute yourself. See, pi n means we are considering only the terms which are having the highest degree, if n is the highest degree term. And there we substitute y equals to m and x equals to 1. Okay. When I'm writing phi n minus 1 means we are looking at, see, let me explain here what is phi n minus 1. So phi n minus 1 is in the original equation, all the degrees having n minus, all the terms having n minus 1 degree, and there we substitute y equals to m and x equals to 1. Okay, so that's what I'm writing here. Put y equals to m and x equals to 1 in all the terms, or all the highest degree terms, all the terms having degree 3, having degree 3. Okay, got it? So here now if you substitute, what you are getting here, pi n means we will write phi 3. So m cube plus 2m square plus m. Okay, so this is your phi 3, or you can also write it as phi 3. It's a function of m since we are putting x equals to 1. Now similarly we will look at phi 2. Okay, phi 2. So there are no second degree terms, so phi 2 is 0.
0. Yes.
Okay, because no terms of uh, no terms of degree 2. So here minus m. Okay. So here again m equals to y equals to m, x equals to 1 in degree 1 terms. Okay. So what is the next thing? Okay. Next we will set this phi in the highest one. Okay. Phi 3 as 0. Putting phi 3 of m equals to 0. So it the terms you see m cube plus 2m square plus m equals to 0. Okay, so we will be getting the value of m
M equal to 0
okay,
minus
M
1.
if you
equal to
take common
minus
m,
1,
then we have m
0.
square plus
0.
2m plus 1. And yes, what happened to my one note? Sorry. It's a very direct way, okay, and almost all the times it works. You may not get in that technique, but you will be getting in this technique, okay. So it's not there in your book, okay. I mean, like you do have some shortcuts there, but it works good. So that's why I thought I should. Okay. So m equals to what we are getting is.
Ma'am, your screen is not visible.
Yes, ma'am.
Yes, yes, I got it because one note it was just stopped. You try for both the cases. It's a little bit left. Okay, so m we are getting here
Minus 1,
0
0.
minus 1 repeated. Okay, two
Yes, ma'am.
times. So now we will look at these equations are there. Okay, here we add phi n minus 1. So here the first equation, we have set the first one 0. Now we will look at this one, b by 1 factorial plus
B
5.
square by 2 factorial.
No, first b. Whenever you go for second derivative, see while second derivative b square, third derivative b cube. Got it? B square is in the, we are looking for the first done, second one. So if you get it from the second one, there is no issue. See here b into, see when this is actually the function is a phi 3m. Okay, so phi 3 dashed when I am writing it is with respect to m. Okay, so if it is m cube plus 2m square plus m, so this will be 3m square plus 4m plus 1. Okay, so here phi 3 dashed will be 3m square plus 4m plus 1, and phi 2 is 0. Okay, we're using this one to get this one. So you actually what you did, you are actually up to this one. Okay, For m equals to 0, we are getting actually b equals to 0. So you're saying no oblique asymptotes. Okay. But if it's not working, we will go to the next one. Okay. So the next equation is b square by 2 factorial 5 3 double dash plus
Double.
b pi 2 1 dash here. Okay. 1 factorial. This is 2 and this is 1. This is the next one. Okay. If it will not work, you have to move on. Okay. But you don't have to go far. Okay. So b square by 2 factorial and 5 3 double dash here. So here we are getting 6m plus 4. Okay. So 6m plus 4. And here b pi 2 is 0. So this is 0. Okay. This term is 0. Now you look at the phi 1. Phi 1 only one term. It is m. Okay. Phi 1 is minus m. Here we have done. So phi 1 minus m. Okay, now you can solve this one. This term is 0. And here we have, okay, so you put, we have already m equals to minus 1 value. So m equals to minus 1, we are getting c equals to plus minus 1. Okay, so m equals to minus 1. We have two things, c,
B equal to
sorry, b.
B
b
equal to
equals to plus 1, b equals to minus 1. So here we have this y equals to mx plus b. So minus x plus 1, or you may write it this way, minus 1 minus x okay. So these are the two asymptotes. So how many you got it? Two asymptotes. This one is oblique asymptote, this is also oblique asymptotes. Further you can also write, right, x plus y equals to 1 and x plus y plus 1 equals to 0. So these two, and here I think,
4 total.
so y equals to 0, this highest degree term. Okay, I directly went for the oblique one. Okay,
Y
so
equal to
here
1
you will be
minus
x square. Okay,
1
there won't,
minus
if you see here, no, I'm talking, we are already getting two oblique one. Okay, I'm talking about if you are, it's a third degree equation, there will be maximum 3. So I didn't check the
y equal to
vertical
0.
and y equals to 0, one horizontal one come. Okay, for y cube, coefficient is constant, so no horizontal one. Sorry, no vertical one. Okay, so here no vertical asymptotes, and here we are getting y equals to 0, the x-axis and horizontal. Okay, asymptotes. One horizontal asymptote, two oblique asymptotes. Okay, this is the third degree equation. Okay, so three. This is how we are getting. Okay, got it. I've shared this one, no, one note with you.
Yes, ma'am.
So go and this the problems are all still there. The second one you have to find the oblique asymptotes. Okay, try with this method whether you are getting or not. Okay, and the third one also. Third one you try with normal method or in this method both. This
Third
equation.
one,
The second one, there will be oblique one will be there. No oblique asymptotes. Okay, the second one, no oblique asymptotes you are getting. But that method I told you. Okay, where is okay, no oblique asymptotes. That's true. Okay, so you try for the third one. Okay,
three
Ma'am, then
oblique.
two asymptotes only.
oh, it's okay. Maximum three asymptotes. No, in the second one I'm saying the questions I have given. The last one I already did. The second one, this one. So it's a
second
fourth
one,
degree.
three
Three
asymptotes, ma'am.
asymptotes, two vertical, one horizontal.
It's a fourth degree equation, so maximum 4. So it can have 3. It is having 3 asymptotes. Okay. So the last one is left to you. You do it or we will do it.
Three oblique.
The last one, 3 oblique.
Yes, ma'am. Y equal to x, y equal to minus x by 2 plus minus 1 by 2.
The which method? By putting y equals to mx plus c.
Yes, ma'am.
Okay. So here this one, you can see the coefficient is constant. So here no horizontal, no vertical asymptotes. You can see if you have the constant coefficients of the highest degree of y and x, then there are no correspondingly asymptotes. Okay, for this one, no vertical asymptote, no horizontal asymptotes, no vertical asymptotes. Okay, 3 oblique asymptotes you are getting. So third 3-degree equations, do it. Okay, and if you want, you can further do the exercises also for the asymptote. So your first module is complete. So first module is on, and let me see how much I am doing for the differential equation.
Ma'am, two asymptotes coming for the third question.
You
Okay,
try
ma'am.
with this method, the
Plus
one I
minus
told you.
1 by 2.
Y equal to x and y equals to minus x by 2.
And what is the other one? You said someone said no 3.
And y equal to minus x by 2 plus minus 1 by 2. Two asymptotes, another y equal to x.
Okay.
I'm also getting 3 asymptotes, ma'am.
Y equals to x is one asymptote. Only I am writing the
Minus
one is
x by
y
2.
equals to x, and then y equals to what you said minus x by
Minus x
2
by 2.
plus
Plus
1
minus 1
by
by
2,
2.
then minus other one is minus 1 by 2. That's what you said.
Yes,
So
ma'am.
check. Okay. It's coming by putting y equals to mx plus c.
Yes, ma'am.
You can also try this one, this method, the one I told you, whether it's working. Okay. So first module will come, sure. Now for differential equation, I will see how far I'm going. Okay, at least first few 2 3 parts will come. Okay.
And the
Otherwise,
complex numbers part that you taught in the first class.
no, complex part won't come because I will start again. Okay, this very few idea I told you that won't be there. We will do it again. Okay, it's time. So let's stop here. Okay, let me talk to your CR because few at least should complete 2 3 classes. 1 or 2 classes we will be getting. Okay, let me talk to them. I'm ending the class.